Good afternoon, everyone. My name's Infrared, and this is Meshtastic 101. I will try to answer questions at the end of each slide. Just raise your hand, and I'll be reviewing the audience-provided questions at the end of each slide. If I remember, if I forget, we'll get there. I don't expect everyone to retain everything I'm saying. It is an enormous info dump, but the slides are already published, and you can go review them at a later time. There's also at least an hour after this talk just to mingle and talk to everyone, so we'll try to get everyone as informed as possible during then. A little bit of boilerplate. My name is Infrared, and my opinions are my own. They are not my employers, and they are not Meshtastic's. Meshtastic is an LLC. It is an actual company. They employ developers, and they publish the firmware. So they have an interest in protecting their trademark. The Meshtastic logo trademark is the trademark of Meshtastic LLC. They made me say that. So what is Meshtastic? Meshtastic is like a walkie-talkie, but for text messaging. Despite what some YouTubers claim, it's not a cell phone killer. It can't do voice. It can't do pictures. It can't do images. It's not even nationwide. You aren't throwing away your cell phone, and most devices actually need the mobile app to work right. It's really long range, but it's really low data rate. Even text messages have a 200-character limit on them. The firmware that runs on these devices, called microcontrollers, is completely open source. If you want to read and modify and redistribute the source code, you can. It is sent out under the GPL 3.0 license. If that doesn't mean anything to you, don't worry about it. The actual radio style is called LoRa, or long range. It's like how Wi-Fi is its own thing, Bluetooth is its own thing, cell traffic is its own thing, LoRa is its own thing. It requires physical hardware, and you have to get a device with a LoRa chip on it. So you can't reuse the old Arduino you found in your junk drawer. Luckily, they're really, really cheap, like 30 bucks cheap. If you're familiar with IP networks, then you'll know that networks kind of have hierarchies where routers and DHCP servers kind of have an authority. Meshtastic has an authority, but it's a little bit lower. It's more flat. Everyone is kind of routing their own stuff. We're not super dependent on existing infrastructure. Existing infrastructure helps, and it helps tremendously. So when possible, we all want to cooperate, work together, make a good mesh, because decentralized does not mean unorganized. The important part is that all the packets are ad hoc. They do not rely on routing tables or pre-configured routes. Each packet figures out its own way around the network, so they work really well when you're hiking or when you're driving or when you're out in the field. They also work really well when you have a static mesh like we have here in MSP, but they work a little bit differently depending on how you set it up. We have them set up pretty good, so if you follow the latest guidelines on the MSPMesh.org website, you'll be doing pretty good. The devices themselves, we call them nodes. Please keep that terminology in your back pocket for later. Mesh is not exactly hub and spoke like your Wi-Fi is. It is not each device having to connect to a mothership and then back to another device. Two devices can talk directly to each other and back and forth, or using a third intermediary node to get the range you need. There are no central authorities in this mesh, besides, the organizers trying to keep everyone on track, but you don't actually have to listen. Normally, you'll use an app on your phone to compile a message to your handheld node via Bluetooth, which actually sends the text message as a radio packet via LoRa. This packet has a hop limit, and if another node receives it and then rebroadcasts it, it'll remove a hop when it does that. So we got the mobile app. Type in your message, it Bluetooths to your node, the node sends it via LoRa many, many miles. Bluetooth can't do many, many miles. Nodes can have different roles that affect rebroadcasting behavior. A client mute node, which we asked everyone to be on this morning, never rebroadcasts, so they're really good for pocket nodes. A router will rebroadcast everything it hears, so they're good for the tops of buildings, but they can be very damaging if you stuck one in your basement, because nodes set to client, if they hear a router nearby, will not rebroadcast, even to the detriment of the greater mesh. because clients can choose whether or not to rebroadcast. So role choice is very important for your own nodes. So to recap, mobile app is what you'll normally use. Bluetooth to your node. Node could be many, many things. We'll get into that later. That sends over LoRa from node to node to node to node, subtracting a hop each way, which the hops that you set, normally it's at 3. And it goes really, really far. You can talk between different nodes for blocks. You can talk for miles. You can talk for dozens of kilometers if you have it all set up right. So when you set out a message, based on what you have configured, the default is 3. It can go up to 7. You send out a message. You say hello with 3 hops left. When hello reaches a rooftop node, it'll subtract a hop and then send it out again with 2. Then it'll hit another neighborhood, send it out again with 1, and then it receives your buddy. This hop limit is to prevent messages from going back and forth, getting nowhere. There are many different device types. These are not the roles that I was saying earlier. They're a lot more generalized. We have pocket nodes. These are the ones you carry with you. These are most of the nodes you're going to find out there. Almost always you pair them with a mobile app, and they are the people. When you want to find someone, you're going to be finding their pocket node almost all the time. There are static infrastructure nodes. If you've seen on your node list any of the gateway nodes or RV3 or TTT, they are unmanned. They're unmanaged. No one's actually checking their messages. Stick them up on the top of a tower, come back in a few months if they break. There are also vehicle nodes, which we use kind of like rolling infrastructure, and you don't message them directly, unlike if you're familiar with a ham radio or GMRS, where they'll turn off their hip radio to turn on their car radio. We don't really do that. We try to stay connected to our pocket nodes at all time. And then since LoRa works best with line of sight, we really want to have as many people getting roof nodes up over pocket nodes. So we can go from your device, go up, go across, and then go down to someone in their house or on the road or in a protest or hiking or boating or whatever you want to do. We're just trying to make the roads. I don't care who drives on them. I don't care what purpose you use. And we will all just have a wonderful time. If you really want, you can also have desktop clients for if you have if you're home labbing or something, or building a cyber deck, or if you just have your laptop here on a podium. I broke it. It's fine. Some nodes, like the LilyGo T-Deck, have their own keyboard, and you can use them without the mobile app to an extent. You need the app to do some things even today, but you can do a lot with this little guy. If you want to leave your cell phone at home for some reason, or if you're camping and you just want to have more of a, leave your cell phone at camp so you're more one with nature, but if you still need to communicate out if something goes wrong, this is a pretty good node to have. This one is about $100. First time setup. Step number 1, plug in the antenna. I cannot stress this enough. If you power on a device without an antenna plugged in, all of the transmission power is not going to radiate out into the environment. It's going to hit the end of the wire, bounce right back, and fry your radio. I have one fried on me right now. It does happen. When it's all set up, you got your antennas, you got your batteries, it's plugged into a case. You'll want to get the Meshtastic app on your phone and then hook it up to Bluetooth. You can hit scan. You're going to see a whole lot of devices. Connect to it. The default pin is 1, 2, 3, 4, 5, 6. If it has a screen, it will show it on there. This is entirely dependent on whether the device detects the screen, at least for first-time setup. So if your screen is broken, you can try 1, 2, 3, 4, 5, 6. You can connect either via Bluetooth or you can connect via a USB cable directly. If you have Android, you can use a USB serial device right from your phone. Otherwise, USB into a computer also works just fine. Next, you'll want to set your region. You want to set this to US. There are no other options for us Americans. You will then set the short name and the long name. If you printed a name tag, you'll have noticed that the printer has the long name BBS printer and the short name BBSP. The short name is what shows up on your node list under these tiles, and then the long name is obviously longer. In the actual chats, you'll see everyone's short name there more prominently than the long names, making them kind of a shortcut or a nickname for your regular node's name. Nodes also have a node ID. This cannot be changed. The short name is max of 4 characters or 1 emoji. If you make it an emoji, it'll be a very big emoji on the app, and that's very nice to see. As the mesh evolves, so do our practices. Since inception, we've moved from the default of long fast over to medium fast, which has a different data throughput and a different frequency itself. In the future, we may change presets again. You should check mspmesh.org/settings for the latest best practices, not just the LoRa preset, but also telemetry timings and environmental timings and other node info broadcast intervals. Background data that humans don't really care too much about is the biggest source of traffic on the mesh. And we've already hit the ceiling of how much a mesh can hold once before, and we're pretty close to it again. So please, please everyone, check the website and set them. While a mesh is decentralized, that doesn't mean unorganized. Please work together. Lastly, some devices had their firmware flashed at the factory wrong and have the same key pair as every other device. If you worked at all in cybersecurity, you know this is a no-no. Particularly the Seed T1000E had this problem. So when you flash your new firmware, please regenerate the keys in the mobile app. This is under the security section, and there's a big green button called Regenerate Private Keys. Let me double check some questions because we're 6 slides in and I haven't checked them yet. How well would this work for tracking a long distance bike ride? It would work okay, but you'd have to be in service the whole time because packets are not held on and then sent out when you're back in service because there is no service. There's no cell tower always saying you're in range or you're out of range. You send out a location packet, and like a walkie-talkie, if you miss it, you miss it. When traveling abroad, is it easy to change region without losing the US node list? I don't know. You should be the first one to try and then report back to everyone. There's actually quite a lot of that here in the mesh. There's very little experts on everything that's going on. I don't know a lot. I know a good amount. I've been here for a while, but I don't know everything. I don't know all the ins and outs. I'm not all that familiar with, the Linux or the software side. There are other people who are really specialized into that, but don't know anything about battery building or telemetry logistics. And the people who are really into battery building, maybe they don't know how to climb a tower and put something up. Maybe they don't know how to talk to farmers to get on their silos, or they don't know how to talk to business owners to get on top of their factories. We all kind of do our own thing as best we can, and together we make a fabulous mesh. And so far we actually have. We have one of the best meshes on the planet. Just for the microphones, to reiterate what Bruce said, US devices operate on 915 megahertz, and that is not necessarily the frequency that you can use in other countries like Europe or Asia. Asia, I think, uses 433 megahertz. Europe predominantly uses 868 megahertz, which are not fundamentally compatible. The LoRa radio in this device is a specific 915 megahertz chip. It is a hardware chip, and you can't tune it to 868 or 433. That's, if you go to order some nodes online, you're going to notice that there's a drop box you have to choose. You got to choose 915 US. When you're selecting your region at your first time setup, you have to select United States. That is also doing some frequency stuff. What could I be doing wrong or setting not right if I'm able to traceroute but messages fail? If you are direct messaging, direct messages are encrypted with the public key of another node, and they use their own private key to decrypt it. If you have not done a proper node info exchange, or the keys are wrong for whatever reason, you will not be able to DM. You should still be able to send messages out via the public channel, because the public channel for most of us is unencrypted. As far as the antenna being removed at the inappropriate time, how do you tell if it's damaged? If it is rebooting every 30 seconds because it can't detect the actual radio, the firmware will be like, hey, I can't find the radio. Let me reboot and try again. It's going to keep doing that forever. Sometimes you can also hold your ear up to it and you can hear it going beep. That's physical damage. I have one I can show you after the talk if you guys want. Channels, DMs, and telemetry. Oh my. Channels are shared group chats between many nodes. When you first spin up your node, you'll see the firmware default of long-range fast data. As a group, we've switched to medium fast. Slightly lower range, but about 4 times the data throughput because we have too many nodes for long fast to handle, even with our telemetry tunings. The primary channel, or channel 0, or medium fast on the Android app, is where most of the actual data goes through. By default, it's unencrypted. Node info broadcast, most telemetry, and location travels via the primary channel. All channels on your node have to follow the same LoRa preset, such as medium fast. You can have additional channels, and those additional channels can be encrypted, but they all must be either all long fast or all medium fast or all short turbo or whatever. You can't mix and match them. When you send a message in a primary channel, any acknowledgement that receives, when a node receives a message, it's going to send an acknowledgement back, just basically saying, gotcha. Not a huge message, they're pretty easy to send. When you receive it in the group chat, you're going to get the little cloud delivered. If you're sending a DM to a direct message to another node, and someone hears it and relays it, you're going to get the check mark in the cloud. When your intended recipient receives it, you're going to get the person with the cloud. Sometimes you can send a DM and it's not going to get delivered. It's going to say it's en route, and then it errors out. It's sent out, maybe someone heard it, but you didn't necessarily receive the acknowledgement back. And then it's going to try again. And you can be getting out and not be getting in. Sometimes we call this the alligator problem. You got a big mouth and no ears. Sometimes you got the opposite. You can hear a lot, but you can't get out. Finding a good balance is quite difficult, and usually the easiest way to do that is to stick a node up on your roof. Sometimes you can send out to a DM, you can send a DM to someone, you'll get the delivered, but you're not going to get the check mark for the person. It might have already gotten to them, and they might be replying, but you can't tell because you can't hear from them. And then, now you got to figure out, are you receiving me, or am I not receiving you? What's going on with that? This is called, in computer science, the two generals problem, and if you can solve it, you'll be very rich. So please tell me if you manage to do that. Telemetry is most of the background data that you hear about. It's most of the data on the mesh, and it's primarily node info packets, location. If you got smart location, it's going to send an info ping every time you move more than 100 meters. Various sensors like the battery state of your pocket node, the battery state of infrastructure nodes. You can do weather, you can do humidity, you can do air pressure, you can do ionizing radiation. But we don't want to hear most of this data. I don't think anyone actually cares if my TDEC is on 80% battery. So I just turned it off. We don't have the data throughput to have that kind of info coming from everyone's nodes. So if it matters to you, go ahead, turn on that telemetry. The telemetry that it sends out still follows the same hop limit that the rest of your messages do. So if you set your nodes to use 7 hops, all your telemetry is also going to use 7 hops. If you have a dedicated node that only does weather sensing, then if you're only 2 hops from it, set it to 2 hops. I don't think anyone cares if they're more than 3 hops. The Meshtastic ecosystem supports a lot of stuff. Temperature, humidity, battery voltage. You can do soil humidity if you're a farmer. You know how many satellites your GPS node sees. You can do ultrasonic distances. There's a lot of cool stuff, and it all follows the same mesh infrastructure. So if you have your soil sensors out in a field, they can all go to the top of your silo, and then the silo can talk to your house. And you got all this cool, really cool information, maybe really valuable information. Just use it for good. Is there an effective limit in the mesh with regards to private channels? It is effectively the limit of the mesh itself. Nodes can redirect messages, it can rebroadcast messages that it doesn't understand that they are encrypted. As long as both nodes are using medium fast and it is following the default settings, if you have an encrypted channel as a secondary and you want to go talk to your friends across town, as long as your primary channel is still medium fast and unencrypted, your private chats will follow the same infrastructure, but we can't hear it because it's encrypted. It's not, the most encrypted. It's not going to help against a state actor. It's not going to help against Russia. It's not going to help against physically tracking down your data, or if you've seen the XK's CD comic, it's not going to help you if they just go find you and beat you up. But your encrypted messages will follow the existing infrastructure that we already have. Any questions so far? So that does get a little bit into RF theory, antenna theory, and kind of Meshtastic 102. But in general, each packet takes a certain amount of time, no matter kind of how big it is. And once you hit about 50% what we call channel utilization, there's telemetry for that. You can go check on your own node. Once you hit about 50%, it's waiting to broadcast as much as it is actually broadcasting. And so some messages just never get a chance to go onto the air. After a certain amount of time, if you send out a message and it's like, I just can't find a way, I can't find time to say it because you can't talk over each other. If you're ham, you're probably familiar with simplex radio. It's pretty similar to that. If it never gets a chance to speak up, if everyone's talking over it, it's just going to give up and it's not going to send your packet. And that is what we call the limits of the mesh.
The RF band.
Yeah, so it's because the medium fast preset, the medium range fast data, it's configured, there's numbers that says, okay, I'm going to send my chirp. My chirp is 1/10 of a second. There's only so many tenths of a second in a second. So I hope that helps. Yes? The firmware limit of hops is 7. If you were to hack the firmware and say, oh, I actually have 10 hops now, by the time you hit the next node, they're going to drop it down to 7, or maybe 6, I'm not sure. Each hop can go pretty far. If you can see it, if you got line of sight, if I had a node on the International Space Station, it flew overhead, we could talk pretty reliably. But that means everyone in its range can talk. So if I were to stick a node on the ISS and it flew overhead, it would be able to talk to so many things, the channel utilization would instantly peak and no one would be able to actually say anything. We could actually see this last summer when someone in Chicago launched a Meshtastic node on a suborbital balloon. I was able to talk to nodes in Chicago very briefly, but because there was so many things talking to it and it was so high up, it drained an entire 18650 battery in an hour because all of that energy went into transmitting. So these mesh limits and how far you can go, I think the record, the land-based record, is about 200 kilometers. That was it was 200 miles. So it was a purpose-built kind of highway that they did up in the mountains. I believe it went from the Rocky Mountains over to Montana, something like that. But that was kind of purpose-built, and they scouted locations for it. Our mesh, we're seeing 100 kilometers, maybe. 70 kilometers. And once you get to so many nodes when you got so many big nodes in your hop range, if they can see so much, eventually someone in there is going to hit the channel limit and there's going to be a bottleneck somewhere. The mesh routing algorithm that each node uses is kind of smart enough to be able to get around obstacles because it's all, if a node is so busy it can't rebroadcast it, other nodes are going to be like, oh, that never got rebroadcast. I got an opportunity. I'm just a client. So I didn't see anyone do it. I'll do it, and maybe it'll get around. But like all mesh messages, it's actually a maybe. I don't know if it's going to get across. It might have got across yesterday, but it's not going to come across today. It is what it is, and we're all just kind of working towards it. The free hops kind of came out after I started designing this PowerPoint. Nodes, infrastructure nodes that are high up on buildings, like if we got RV3 and Turbo Tims, if they can directly talk to each other, if they are both routers, the latest version of the firmware, and have favorited each other, so they, like if you've seen in the mobile app, you can favorite a node, infrastructure can do that. Packets will actually go between those two without subtracting a hop. So you can make superhighways, across great distances that'll not remove hops so you can get much further. You can have 9 hop messages, 12 hop trace routes, but it directly impacts the limits of this mesh that we've been talking about. Removing telemetry helps with that. Okay, so he asked if there's a way to bridge different frequencies so we can have a information highway on, say, short turbo that goes way faster but is less reliable. If they're line of sight, it's pretty darn reliable. Yes, you can do that. It's very experimental, and I don't think anyone's using it yet. Node roles. In the app, you can select different roles. If you were on the Discord this morning, you see we asked everyone to set theirs to client mute. That is one of these roles. A poorly placed node in the wrong role can damage the mesh. So when in doubt, use client mute. If it's inside, client mute. If it's outside, you can try client, but please check the MSPMesh website. If it's in your pocket, it's a client mute. Client mute never rebroadcasts, never sends an acknowledgement for public messages, but it will acknowledge direct messages. Some people had questions on that earlier. Clients will selectively rebroadcast based on signal strength and if it hears another rebroadcast. If it hears a message that's very strong and then no one else rebroadcasts, it'll rebroadcast. But if it hears it from, if the signal is very weak, it's going to assume this radio is pretty far away. I should probably rebroadcast. That'd be good for the mesh. It's not the perfect algorithm, but it's good enough. Clients wait about a second before rebroadcasting, so routers have a chance to do it first. Routers will always rebroadcast, no matter what. If it hears a message, it rebroadcasts it as soon as it can. This makes them very powerful, but a router in a basement is always going to rebroadcast, and going through a basement is going to have a pretty bad impact on the signal. So if there's a better node nearby that's a client, it's going to be like, oh, this router rebroadcasted, I'm not going to do it. And then suddenly you got a packet black hole because some guy thought he was helping, and they're not. Please don't make routers. We usually get community consensus with it. We start a thread on the Discord. We analyze, how far can it see, what kind of traffic is it getting here. If you're going to set one up outside, set it as client, wait a few weeks, collect some data, come talk with us. We'll figure out if it's a good router or not. Router late is a role that's like a router. It rebroadcasts immediately. Well, it rebroadcasts everything, but it not immediately. It waits until the last slot in the rebroadcast window. This lets clients rebroadcast it first, so a router late isn't very damaging to the mesh. Because when clients choose to rebroadcast, they base it on if they think there's a nearby router or not. They do not make this for a router late. If there's a router late nearby, that doesn't have any impact on whether a client rebroadcasts. And there is now a very niche client-based role, which will always rebroadcast favorited packets designed for the favorited nodes that it has. It's kind of niche. Router late is also pretty niche. If you want more info on it, I don't have a ton, but if you go in the Discord, we'll certainly try to help you out. I just haven't played with it too much. Client base are designed for vehicle and rooftop nodes, usually recommended over router late in most scenarios. My car node is a client base. I log into it. I favorited my pocket nodes. My pocket nodes favorited the client base, and that usually, I think that's all you need to do. I'm not totally sure. Like I said earlier, a lot of this mesh stuff is cooperation and working together. I don't know everything. You don't know everything. Together we know some things. There are some additional niche roles I haven't played with too much, and most people haven't either, like client hidden and tracker. These are designed to change its priorities, where they will wake up and rebroadcast some sensor info and then fall back to sleep again. ATAC, the TAC and TAC tracker are for ATAC and CivTAC if you are into those things. I am not. If you do play around with them and you get some solid information, please post your findings to the Discord. I'd be interested to see them, and I'm sure a lot of other people would too. If you make a pull request to the documentation website on meshtastic.org, you get a cookie. Is there a way that telemetry can be constrained to only DMs? It kind of is. It kind of isn't. It already travel, even if it would be a pure DMs, that information would still travel via the public mesh. So it actually wouldn't do anything for the actual traffic limits. The only thing that could do is it would make it hidden so no one else can see your telemetry. There's a way to do this by turning off telemetry for some things in the public channel. You can turn off transmit, and then it'll like kind of select the lowest channel that it can, at least with location. I can't answer your question. I don't actually know. There are many hundreds of nodes at OpenSauce. How did they do that without oversaturating the frequency? They had their own firmware specifically for that event. They were all set to 0 hops. They all had the short turbo preset. The Meshtastic developers themselves made that firmware version. We do not publish our own firmware. We're kind of just working with what they got and have made for us. We're concerned here with a few hundred because we're working on kind of open limits. We didn't tailor everything. The tailoring that we're doing is on the MSPMesh.org website. Please visit it. Is there an effective limit in the mesh with regards to private channels? The limits would be the same as with public channels because if you want to use our infrastructure, we are all sharing channel utils and airtime utils. The amount of traffic they can send on private channels is exactly the same because they're using a shared resource. Would a vehicle node be better as client base or router late? Not much difference. You should use client base. What's the best node roles to use in trying to keep in contact with areas without infrastructure, such as festivals or hiking? Then you would use client, because clients, when in doubt, use client if you don't have existing infrastructure. Since we do, we're kind of tailoring it and kind of figuring it all out. If you're out in a festival or when you're hiking, stick it to client. If it's like Burning Man, they kind of have some infrastructure there, so you could try client mute. It's probably going to work, but client. That was because we did have an overabundance in routers around the cities. We set everyone who had a router late or everyone who had a client router, we had set to client for a while, and some of the best nodes to come out of that were set to router again. Shortly after that experiment, client base came out. So a lot of us are using client base now. Yes, but sometimes you can use routers to kind of force packets to go where you want them to. This has the direct drawback of a badly placed router is all the more damaging. And because we don't develop the firmware, there's not much we can do about that. It acts as a client. So in all other cases, it'll act as a client, but it just has the added benefit for its friends. You would have to log in, basically. So either connect with Bluetooth, or if you have remote admin or something, there's no way to change someone else's role. You can't outvote them, you can't bully them. All you can do is ignore them. There's no firmware ability to do that. If you had like a Raspberry Pi in your car, you could do it programmatically, but there's no onboard way to do that. I wish there was. Mobile apps, other clients. The most common one you're probably familiar with is the mobile app. Here we have the Android app. The iOS app is fairly similar. They're not exactly the same code base, but they have the same functions. If you are on a computer, you can use the web client. It uses Google Chrome and either Web Serial or Web Bluetooth. You can also connect to ESP32 nodes via Wi-Fi, but an ESP32 node connected to Wi-Fi cannot use Bluetooth at the same time. They must choose. If you are on Linux, you can use Contact. It's a nice terminal user interface. There are also other stuff like there's a Python library, there's Rust libraries, C# libraries. MeshSense is a nice desktop client. It can do automatic trace routes and kind of write down all of the path information that it finds. Please use it sparingly and please don't leave it running. Trace routes use a lot of data and they're pretty hard on the mesh if you forget that it's going. There's also the Mesh Potato, the monitor website that you might have seen on the Discord that has multiple internet hooked up ingesters around the cities, and they all feed a central database. So you can check that website if you want to see if you're on the mesh. But you shouldn't rely on it for messaging because that's just an internet chat room at that point, and that kind of defeats the point. That's also why we don't really use MQTT, because that would just be using all of your nodes to talk to the internet, and we can just do that through Discord. And why would we build this off-grid network if you're just going to use the grid? Devices themselves can also have interfaces. The on-screen, you might see this on Heltex or other cheap nodes if it has an OLED screen. This is called Base UI. Works really good if you just have the one button. You can just kind of start paging through it and do some stuff. If you have a TFT screen, you can use MUI or the fancy UI. The TDEC has it. You can get, this one has a full keyboard, but it's also got a touch screen. You can do some stuff. If you have other devices, you can also get real fancy. This one's basically a tablet. And then if you have an e-ink screen, you have InkHUD. Because it's an e-ink, if you're familiar with that technology, it's really low power draw. It only refreshes when it wants to. So when you power down the node, the screen still has a display. Pretty good for sensors if you want that. I have all three of them on me. After the talk, you can just come up to me. I'll show you around, and you can play with them as much as you want, kind of get the ins and outs. If you're not sure what kind of device you wanted to buy, come take a look at them. They're pretty cool. Node Discovery and NodeDB. On board the firmware in storage, 80 for NRF52s and about 250 for ESP32s and unlimited on Linux, is the NodeDB. It is a database that contains the node ID, the long name, the short name, hardware model, public key, and maybe some telemetry. If you only have a node ID, you'll see this in the mobile app. You just have, 5E0C, Meshtastic 5E0C. What does that mean? I don't know. That is a partial node info. I don't know what hardware model it has. I don't know what its battery life is. I don't know what its role is. I know nothing. Every configurable, which we say try to do like 18 hours, 24 hours, 48 hours for a Pocket node, it'll send out its NodeDB as a special packet. And then it also does this once every time it boots up from dead. That packet also has a hop limit, and it goes around just like a message does. But when your device reads it, it'll stick it into its NodeDB. Then you can favorite it to not get rid of it. You can direct message it. You do need to have its NodeDB to direct message it because its node info contains the encryption key. You can use the mobile app to display a QR code, and you can just scan each other, scan their app with your phone, and you can add them to the DB directly. The mobile app can extend the NodeDB. So my Pocket node only holds 80. It's an NRF52. But according to my phone, it knows 1200. That's because the phone extends that. And then additional nodes that fall off, when they get rotated out with fresh ones, they'll go onto the phone, and it'll hold on to them. If I were to switch my Bluetooth connection to another node, I would lose all of that overflow. So it's important that you should favorite nodes that you don't want to lose. I have favorited all of my personal nodes as well as the printer, because the printer's a little bit picky when it comes to exchanging its private keys. When a node boots up, it'll always send out a NodeDB. A node that has never heard that info before will immediately send out its own to Handshake, unless it did so less than 5 minutes ago. It does not check if there was a response. If it missed it, it missed it. You can either share the QR or you can reboot both nodes to have them handshake again. Some real-world use cases, like what we got, a static mesh. We use routers and client base and other kind of trickery in order to kind of move the packets where we want them. We're kind of like herding cows or sheep or cats. We've been able to manually tune the packet flow to get as high of a range and as high of reliability as we can. When you're hiking, you don't have a skyscraper to stick a node onto. All of your packets are going to kind of be moving around on the fly, going in and out of range of each other, and they're not going to know when they're in and out of range because they haven't set the packet yet. So in that case, I would recommend stick them to all clients. If you're going to be boating, open water, you can have, there's a bridge called Signal K-Meshtastic. It bridges Meshtastic and Signal K for marine radio and boat tracking. Because you're on the water, line of sight's pretty good. The movement of packets is entirely determined by who can hear you and whether they choose to rebroadcast. And hops remaining, of course. Besides a little bit of what's called next hop routing, which is a little bit of an advanced feature I don't know too much about, if you're going to do a open message into the public chat and you think you can get there in 5 hops, try 6, because you don't know, even if you hear them from 5 hops away, the next time you hear from someone, it might be 6 hops, it might be 7 hops, it might be 3 hops. Because every packet goes out and figures out its own way as if it's the first time it's ever doing that, it's not going to take the same path every time. It doesn't go to something. Everything gets it if they're going to get it. But the router will rebroadcast first because it does so. All clients wait about a second to see if a router will have rebroadcasted. And if a client hears a router rebroadcast, it'll stay silent. It's not going to redo it. It's just going to drop the packet. With firmware versions above 2.6, you can do something called next hop routing, where direct messages that successfully make it to another node will do their darndest to use the same path. So if one node hears a DM go through and then it hears a packet, it's going to kind of remember that. It's going to remember it came from here and it's going to here, and it's going to try to do that every time. And when everything in the chain does that, you have very reliable messaging after that. But this requires a relatively recent firmware version. We have not really done anything with Meshcore. We're almost exclusively Meshtastic. Any Meshcore experimenting is on an individual basis. You should probably avoid the default long fast frequency if you're going to be using the 900 megahertz airwaves for something else, because they are an open platform. We have a maximum transmission power of 1 watt from the FCC because we can all use it, so we all kind of have to behave. If you have a SDR, you can go check what's in use around you and see if you can find a quiet area, but it's probably going to be pretty noisy no matter where you go. I would just recommend, if you can, if you're going to set up your own presets from scratch, might as well avoid one that Meshtastic already uses. DMs would always travel along the same way that node info travels. So if you have 2 fresh nodes and you set them up where your channel 0 or primary channel is encrypted, and then you have an unencrypted secondary channel, the only nodes you're going to find on your node list are going to be the people that you've shared a private key with. So you can send messages to each other. You will essentially have your own mini mesh that uses our larger mesh framework. And this is totally an acceptable use for it. That's okay. We make it for free, and you can use it for free. But you will not be, if you want to participate in the main mesh, you have to have medium fast unencrypted as your primary channel. If you just want to use it, you can do whatever you want. But if you have medium fast unencrypted as a secondary channel, you're not going to see everyone populate in your node list, and you're not going to be able to DM random people that are only on the unencrypted mesh, because you're not going to have them in your contact unless you do the QR thing. Does that make sense? If you disable location sharing on the, if you have, the most common setup we're going to see is we're going to see unencrypted medium fast as your primary channel. This is where location goes. If you disable location sharing on medium fast and you enable it on another channel, it's going to send location on the lowest number channel that it can. So if you have it off on channel 0 and on your encrypted channel 1, it's going to be shared via the encrypted. So if you have a small core group of people that you want to help share precise location, like as accurate as it'll go, in the app, everyone's got their node on you. We're going to go search for survivors or something, but not on the unencrypted mesh. That's the way to do it. You disable location on channel 0, enable it on channel 1. You can share it while still participating on the unencrypted mesh. It does prioritize weaker signals to rebroadcast just under the assumption that it's farther away. This might be, it could be just in a basement but really close. There's no way for it to actually know, and I don't believe it uses location packets to assume a location. I think it's entirely on timing and signal strength. There would be, every time it boots up, it thinks of a random number and it makes a random delay on top of the 1 second delay. So to help reduce collisions is what we call them when 2 nodes broadcast at the exact same time. On startup, it makes a secret key and it'll wait 0.072 seconds instead of 0.89 seconds. And the chirp should be quick enough that it can kind of detect that. It's not perfect, but they do their best. The repeating node only changes who repeated it and the hop count. Everything else remains. When you send an encrypted message, the headers there, like the sender, the destination, the hop count, that part is unencrypted. Only your payload is encrypted, if that helps. No, it would only be, I'm currently sending it, and it removes the last one. It will only send over the lowest numbered one in the app. So channel 0 is almost always going to be your public channel, your unencrypted one. If you disable location on there and enable location on your secondary, that's where it'll go. If you have it enabled on both, it's going to send it via the public channel, which defaults to not precise. You have to actually try to get it to send precise location over the public mesh. I do mean on the app, I mean, this is why I don't love that they're named channels, because there are, like, these are my conversations. I have channel 1, Tree Talk, and channel 2, Medium Fast. Tree Talk is an encrypted. It has its own key. It's really long. It's not the unencrypted one. In the actual node settings, you can find RF channels. So in the app, they call them frequency slots. That's the only way to differentiate them. If you're a ham, if you're a GMRS, you're probably familiar with channels already. These are not those channels. It will probably go to that one first, no matter what you do. If you have a client, there's very little you can do to influence where the packets are going to go or how they're going to bounce around. That is on the role of the infrastructure. You don't have to worry about it. If you can see a router direct, it's going to rebroadcast your stuff. Theoretically, yeah, but LoRa is also crafted in such a way that if you had like a 8 dBi antenna on your roof high enough, it'll do the same thing, but better because it'll get everywhere. If you have an antenna that isn't factory garbage and you can see each other, you can almost certainly talk. No antenna is going to get over the horizon. In theory, yes, but you could also do that double frequency bridging that people have been talking about. We haven't done much experiments with Yagis or dual radio nodes. So if you want to be the first, please give it a try.
Very interesting.
Yeah, try it. Share it on the Discord, see what you get. Probably not. I don't know. Try it. This is a very common theme in Meshtastic. Try things. I don't know. Try it. Share it. See what happens. Worst case scenario, you just take something down. What'd you do? You buy some hardware that we can reuse later? That's fine. Try stuff. Experiment. It's a hobby. You get out exactly what you put into this. MQTT is for sending your mesh traffic over the internet, and then, if you do it right or wrong, back into RF land. We think this kind of defeats the point, so we don't use it. But there is a public MQTT server you can subscribe to, and messages that go in, you can then read on the app kind of as if they're, like, it'll note that it's from MQT, it's from the internet. It's not hidden, but you can be like, oh, I'm using my mesh node for something, but it's just an internet chat room. That's kind of breaking the point of building all this infrastructure. You could not link the meshes because packets that enter the MQTT server set their hops to 0, no matter how many they're at. So that it will not escape back into radio frequencies. You can use a local MQTT server to configure sensors and get a bunch of information pretty easily into home automation systems. If you're in a Home Assistant, just use the add-on from Hacks. It's a lot easier. Minnesota Center is really good. RV3 is really good. TurboTins is pretty good. But any big router will be fine. We tune them pretty good. Please clap.